Let's talk about quadratic function basics. We've already been talking about quadratics when we were looking at transformations, making our functions move up and down. Quadratics was one of our examples, our parent function being y equals x squared. But let's look a little bit closer at quadratic functions. We're going to study them in Algebra 2. They are extensively covered in Algebra 1. So let's review a few things, investigate some new things, and get started. A quadratic function is a degree 2 function, meaning the highest exponent of the variable is 2, right? Y equals x squared is a quadratic. It gives us that lovely graphs a parabola. Below that, I've got some graphs of parabolas. Let's identify some key features of our graphs. First, let's label the axis of symmetry. The axis of symmetry is an invisible line right through the center of our parabolas, showing the symmetry. Cuts it right down the middle. Let's label next the vertex. So that axis of symmetry also runs right through the center and the vertex of my parabolas. Now, depending on the direction of opening, that's why there's two pictures here, that vertex might serve as a minimum, like on the left, or in the right, because it was reflected, now that vertex is my maximum point. Might seem like simple vocabulary, but I promise it's important. Let's next label these x-intercepts. X-intercepts. Now, your x-intercepts can also be called roots, zeros, and what we're likely going to see most of the time, solutions. When we see the term solutions, they're probably asking us about the x-intercepts. The last thing I'm going to label for us are the y-intercepts, where our graph is crossing the y-axis. Let me finish writing x-intercepts on this one in bright blue. And that is it. Next part, the domain, our x values. How far left, how far right does it go? Of a quadratic function, every time the domain is all real numbers. Some of you like to use the cursive R for all real numbers. So think about it. Domain, how far left, how far right, x values. As we look at that parabola, it's inching to the left ever so slightly and slowly. And same on the right, slowly inching out. If we had forever, if we had infinity, it would go all the way left and all the way right. The range, remember, is y values. My range is going to depend on the direction of the opening of my parabola. And we're going to talk about it more in an example below. But it's going to look like this. If we have a nice, happy parabola, my range is going to be all the values greater than that minimum point. All the y values greater than whatever. If I have a reflected parabola, my y values are going to have to be less than or equal to that maximum point. So we'll look at a specific example here in a minute. We've also got here, if you want to find your y-intercepts, you can plug in 0 for x and solve. But it's even easier than that because we're plugging in zeros for x. It's pretty easy to identify your y-intercepts. For quadratic functions, you can write them in two different forms. You can write them as in standard form, which you might be most familiar with, or you can also write it in vertex form. Vertex form we don't see as much, but it is awesome. All of our information is right there. Vertex form gets its name because the vertex is very easy to identify, and I'll show you that. Let's talk about standard form first. It's y equals ax squared plus bx plus c, where a, b, and c are numbers. I gave you an example here of y equals negative 2x squared plus 5x minus 3. You don't have to have every term in order for it to be a quadratic or to be in standard form. You might not have, say, the 5x. It could be negative 2x squared minus 3, and it's still a quadratic in standard form. So what determines the direction of my opening, whether it's a smiley face parabola or a frowny face parabola? So the first box here, direction of opening, you already know this. That's determined by our a value, that guy right in front. When a is greater than 0, or when it's positive, if your a value is positive, you know it opens upward. If a was less than 0, if it was negative, you would have a reflection and your parabola would now be opening downward. Let's look now at vertex form. So in vertex form, it looks like y equals a times the quantity of x minus h squared plus k. I gave you an example here where a, h, and k are all numbers. They have values in there. So let's go down that list as well. Determining the direction of the opening, it's the same thing. The a value is going to do the work. If a is greater than 0, it's opening upward. If a is less than 0 or negative, it's been flipped and opening downward. Let's go back to standard form and look at axis of symmetry. So axis of symmetry is right down the center of my parabola. How will I find my axis of symmetry? Well, my axis of symmetry is going to be x equals will define a vertical line for you when you graph it. X equals negative b over 2a is the formula to find the axis of symmetry of a quadratic in standard form. Got all that? We're going to practice some, don't worry. In vertex form, that vertical line, x equals h. H, do you see the h? Let me circle the h. H, or in this case, 3. Vertex. So go back to standard form, vertex. How would I determine the vertex from standard form? Well, you're going to use your axis of symmetry value, because remember I mentioned the axis of symmetry is also where your vertex is going to fall. Your axis of symmetry is in the center. Your vertex also falls at that turning point of your parabola, so it has to be in the center along that axis of symmetry. So you're going to take that x coordinate from your axis of symmetry and plug it in. Plug the x value, I'm going to say the axis of symmetry, into your function, into your equation, to find y. So you're going to take the x value that you get from the axis of symmetry, plug it into your function, evaluate it, and that'll give you your y, and then you can have your x and y coordinate. In vertex form, your vertex is h, k, right here, the k value. Now, these h's are the same number, but watch out on this h. This is going to be the opposite sign from your equation, and it comes from the fact that our vertex form is y equals a times x minus h squared plus k. So you want to use opposite sign. On this example where it said positive 3 up here, our vertex would be negative 3, 1. And let me also put that here. X equals negative 3. Y y equals 1/4. When we plugged it into the formula is minus. So what would the h value have to be for it to show up in the equation as plus? A -3 plus 1. We would have to have a -3, axis of symmetry, -3 as our x value for our vertex. And then the k, you can just take the k. You don't have to change the sign. Okay, so vertex form, like I said, vertex form gets its name because you find the vertex. You just pluck it right out. Now you change the sign on the h, but it's right there for you to snatch up. All right, let's look at an example. Pull it all together. Here we go. Use the graph to determine the following features. First one, A, the coordinates of the y-intercept. Go to that y-axis. Find that y-intercept. What's those coordinates? 0, 8. Your x value is 0, y value is 8. 0, 8 for that y-intercept. B, coordinates of your x-intercepts. We've got two of them. We've got -4, 0, and we've got -2, 0. C, find the coordinates of the roots. What are the roots? It's kind of a trick question. Kind of want to make sure you are paying attention. Roots is the same as x-intercepts, so those same ones again. D, the coordinates of the vertex. Vertex down here. -3, -1. And E, the equation, this is how Delta Math writes it, I do believe, the equation of the axis of symmetry. So if it wants an equation, you better have an equal sign. It's x equals, your axis of symmetry goes right down the center, and it's crossing my x-axis at -3. X equals -3, equation of the axis of symmetry. All right, on the second page, we are going to find the axis of symmetry, vertex, y-intercept, domain, and range. 5 things we are going to find on these examples. Let's start with number 1. We're going to find axis of symmetry. Now, this is in standard form. Y equals x squared minus 2x minus 3. On your notes, we find the axis of symmetry by doing -b over 2a. On my equation, A is an understood 1, B is -2, and C is -3. So when I plug that in, the formula is negative, then B over 2 times A. That makes +2 over 2, or 1. Or if you need your equation, x equals 1. Vertex. How do you find your vertex? From standard form, we're going to use that axis of symmetry value 1. That's going to be our x. So I already know my vertex is 1 something. We're going to plug x into our function. So I'm going to write our entire function here so you can see where I'm plugging in. We're plugging in 1 for all my x's. And using order of operations, I got -4. 1, -4 is my vertex. What's up next? Y-intercept. The notes say, hey, you want to find the y-intercept? Put 0 in for x. Okay. If you plug in 0 for x up here, what's 0 squared? 0. What's -2 times 0? 0. What do I got left? -3. Y-intercept? -3. Or let me write the coordinates. 0, -3. Super, super easy. Domain. Every quadratic function has the same domain. All real numbers. And range, our last thing. Range. Now, you have to look at the a value. our A value was an understood positive 1. This is positive up here. So since it's positive, I know it's a happy, smiley face parabola. So my range is going to be all the y values that are greater than or equal to what? How low does it go? How low does it go? Well, as low as my vertex goes. My vertex, let me resketch this. My vertex is at 1, -4. That's only going to go as low as -4. So from -4 up is all my y values, all the y values greater than or equal to -4. Notice I use the y coordinate of my vertex. Some students use the y-intercept, but that's not my lowest point. Let's look at number 2. I'll show you on number 2 as well. Number 2, let's find the axis of symmetry. The formula is -b/2a. My a value is -1, b is 6, and c is -5. So I'm going to have -6/2 times -1. -6/-2 gives me +3, or as an equation, x equals 3 is my axis of symmetry. Vertex. To find the vertex of that parabola, I'm going to take the axis of symmetry 3 and plug it into my equation. A -3 squared plus 6 times 3 minus 5. Now be careful here because the squared is only on the 3. This is still a -9 plus 18 minus 5. Order of operations, 9 minus 5 makes 4. Our vertex is 3, 4. Y-intercept. It's just going to be that c value, that last constant or the constant in your quadratic, -5, or as an ordered pair, 0, -5. Domain for every quadratic, same answer, all real numbers. And lastly, range. So what do we got here? Let's look at our a value. The a value in front was -1. So this is a frowny face parabola. Where's my maximum? My vertex, 3, 4 is my maximum. It's only going to get as high as 4. On the y-axis, it's only going to get to 4. So my range is all the values less than, all the y values less than or equal to 4. Now we talked earlier, some students look at the y-intercept, but it's not. If I sketch this out, 1, 2, 3, 1, 2, 3, 4, there it is, and it's flipped this way. I'm not even close to my y-intercept of -5. If this is 3, 4. So you want to use your vertex to help you identify your range. Last 2 problems, I pulled them directly from Delta Math because I think sometimes students get to these on Delta Math and they're like, what am I supposed to do here? Am I graphing it on my calculator or setting up tables of values? No. Use everything that we've talked about so far in class. So let's see my answer choices. Let's first look at the fronts. Let's talk about those a values when they are positive and negative. This is a big sad face parabola. It's been reflected. It should have a negative in front. So let's look at our answer choices that have negatives in front. Not positive, not positive. So I'm already down to 2 answer choices. We can also use that y-intercept. Here's my y-intercept, right at -2. I think I found the winner. I think it's this last one, this bottom right one. It had a negative in front, so it would be downward facing. It had a y-intercept of -2, so it would cross the y-axis at -2. And that's all I needed to know. Let's do one more and then we're done. Here we go. These, look at this. These are actually in vertex form. As I look at the fronts, they are all positive. I got a smiley face. So looking at the A values doesn't help me on this problem. But let's look closer. In the top left, the vertex being identified here, that's -1, +1. Remember, you changed the signs on that H value. The bottom left, that's representing a vertex of +1, +1. Top right is +1, -1. Remember, I'm changing my signs on the inside one. And then the last one is -1, -1. So let's go to a graph. Where is my vertex? At 1, 1. +1, +1. It's that bottom left one right there. That's the correct one. Didn't do a whole lot of work. I just used the vertex form and found the vertex from the form to match with my graph. So there you have it. Quadratic function basics. Lots of definitions with our graphs, talking about domain and range, standard form, vertex form, finding the axis of symmetry, finding the vertex. Lots of things to review here and practice here. Let me know if you have questions, guys, and I'll be glad to help you in class.